Hey guys, just a really quick introduction to the EEG lab. So we can see here a processing workflow. This is from M&E Python. It's how they suggest we use their packages and libraries. So you can see first we just import the raw EEG data. Next we have some basic filtering options. We're going to get to pre-processed data right here. So the pre-processed data is pretty much just the cleaned EEG recordings with all the artifacts, all the noise removed. Now after that we would get to epoch data, and here is where our experimental design kind of requires a small deviation. Here is we do not have epochs necessarily in our original data in the way that they are necessarily looking for. So we'll cover that in a minute. First, let's keep it simple and we'll go over raw data and pre-processed data. So for the raw data, we are simply reading the EEG recording. So if we work through this example right here, M&E Python has a very easy method of reading the EDF files, M&E IO read raw EDF, and we can plot it to see what it looks like. So if we just run this code right here, you can see we plot all of the data, which we don't necessarily want. We see timestamps, timestamp milliseconds, all these other things. And really all we're interested in right now is the EEG data. Now while we're doing the import, we can infer types, which is going to allow M&E Python to decide what types of channels all of these are. And you can see up here really quick, I have also defined the EEG channels and EOG channels. So the EEG channels over here, I have defined the electrode locations in the standard 1020 format. And I have also given it values for EOG channels. So this stands for, eye channels, right? I can't remember the medical definition for O, but these are basically the two channels closest to the eyes. So these are most likely to pick up eye blinks, for example. And so we can use these separately to filter all that data out from the rest of the channels, right? And we'll get into that later. Just a quick explanation of why those are broken out. So when we run this code, we can see that we can plot it with our picks, right? So right here I'm picking EEG channels. So when we plot only EEG channels, you can see we don't have all of those random rows up at the top, right? So that's a little clear. Remember, the original looked like this. This is not necessarily info that we want to bother with on the plots. So yeah, that's IO in a nutshell. Now we can step to the second step, pre-processing. So for pre-processing, it is, we start with all of the same methods of importing the data. So this all builds on the previous example. So now we get into filtering. Now pretty much all of these options are broken out as good as possible. So you can see here, I've gone through the trouble of breaking down this function line by line and explaining what they all do. Now, so after filtering, let's see, I believe I plot an original first. So let's see what I did here. Let's see where I plot. Oh, and these have comments in the output. So check this out. This is without DC removed. You can tell here we have some lines extending well over the graph. We have this kind of mess right here. Now this is with DC removed. So you can see up at the top we have a lot less lines exiting the graph. This was the previous one. You could see we have all these up above the graph here, all over here. So let's scroll down at this same area. And you can see getting a lot more on the graph, right? It's a little improved in that area. So now let's see what we can do with even more filtered data. No, this is the filtered data, sorry. The previous data had DC removed. So you can see with filtering the data, we get extremely clean signal, right? Basically, almost all of this data now fits in the plot. Whereas before, originally, look at how much was just all over the place. So you can really see the huge improvement that that has done. And so after that kind of filtering and pre-processing, we can jump to independent component analysis. Now, independent component analysis is going to do a little bit of what we discussed briefly earlier. It is going to use the EEG channels, or the electrodes closest to the eye, to detect and kind of filter out or repair those eye blink events from the rest of the EEG data. Now, of course, I have broken down this function as well. Now, a lot of these are optional or they have a default value. So you can easily run these functions without specifying all of these. Now, with the right VS Code plugins, you would be able to mouse over this and see all of the examples, all of the options. So what we're doing right here is first we're fitting ICA. We are trying to determine what some of the noise is, where the noise is, and the z-scores for all of those, right? So there's a way to plot that as well, but this is merely one of their built-in functions. So right here, what we can do is we can find the bad segments of data, also the z-scores of those bad segments of data, and we could plot those if we wanted to. Same with the muscles. We can do, they have a method to find bad muscle. We are passing it the filtered data and working on that. Now, we want to remove all of that data right from the original. So we will do simply a method on the ICA to exclude all of that data from our recordings. Now we will have filtered clean data if we apply the ICA to the copy. Then we can pick our channels and plot it. So let's go over the output right here. These should be original. Let's see when we get into the corrected data. Okay, so this is the corrected data. Now, to do some further pre-processing, we can only do it in a Python file, as detailed here, because in Jupyter Notebooks we don't have interactivity. So I'm going to go ahead and open up this Python file. This is called preprocess interactively, and this has some instructions as well. I'm just going to run this, and it's telling us, please review the data. Make note of any anomalies. Use the toolbar to zoom and pan. Press A on your keyboard to annotate and close it to proceed. So check this out. This is the raw data, right? This has not had, this is just an example. Let me see what this has had done to it. So this has not had any filtering. Oh no, this has had filtering. So this has had just basic filtering. Let's see what else we have. Yeah, this is just basic filtering. I don't think I've done any ICA yet. I think that comes after the first plot. No, so yeah, the ICA is actually on this plot. So ICA is already done. So this is just going to be when we are interpolating the channels. So check this out. We can click on the ones that we don't like, right? So we're going to pick the ones with the highest amplitude, the most noise. And when we have those, all we're going to do is click X. So check this out. It's going to interpolate all the bad data. So we can see here those channels that we had selected. They're typically a lot less extreme. They will fit on the plot a lot better. Yes, and that wraps up the pre-processing. This is a PSD plot, power spectral density, and we can simply plot this at the end to make sure our data looks good, right? To confirm the the validity of our data. Because if we had any mistakes in our code, these certain plots like this, they would look crazy. So yeah, this is a good way to validate your work when you're done. And that concludes our introduction to preprocessing. Thanks. Oh, one more thing. You can also visualize the difference between the original data and the, what should I call this? Interpolated data. So right here you can see the before and after, and you can see we've made some pretty remarkable improvements. So yeah, we can see the peaks and the noise are a lot better on the interpolated data. Also, the code will go through and every event that it detects, like eye blinks, it will mark on the data. Now, if you find any events that should be removed, now these aren't necessarily eye blinks, right? Because these are on F7, although they also appear on, I think, FP1. So this may not have been a blink. This may have been just them moving their eye. But in any event, if you wanted to mark this event, you could do, yep, bad, and we could do draggable edges. So we can simply highlight the relevant data. Now I may want to label these a little differently, right? Just to keep track separately, because we don't really know what kind of artifacts those are yet. They may be eye movements, in which case we could filter those out with Bad's muscle. And then when you are done, you will simply close that menu, that window, and it'll tell you the channels marked as bad, the number of eye blinks, and some other important data. Yeah, thanks for watching, and that concludes our introduction to preprocessing.